Okay, problem two. So problem two is for the series below. Okay, so let's talk about the difference between a sequence and a series. Okay, a sequence, as we discussed in problem one, it's a row of numbers. For example, 1, 2, 3, 4, etc., etc. Right? It is a row of numbers. What is a series? For example, the series here, it's an infinite sum of all the numbers. Okay, it's an infinite sum of all the numbers. Right. So for example, the sequence, it could be, so for a sequence, you just need to tell me what is an. For example, for a sequence, an is half, right, to the power of n. So the sequence, it is just 0, that is a0, right, half, sorry, 1, right, half to the power of 0 is 1. So a0 is 1, a1 is half, a2 is 1 over 4, etc., etc. Right, that is the sequence. Okay, what about the series? It's series, it's an infinite sum of an when n is from 0 to infinity. Okay, so it is 1 plus half plus 1 over 4, right, etc., etc. Okay, so when we talk about a series is convergent or divergent, it's different from the sequence is convergent or divergent. So a series is convergent if this infinite sum is a real number, is equal to a real number. Okay, is equal to a real number. Here I can tell you the result is 2. Okay, later we will see why. So if this infinite sum is equal to a real number, then the series is convergent. Okay, if this infinite sum is equal to like positive or negative infinity, or it does not exist, then the series is called divergent. Okay, then the series is called divergent. So let's see problem 1a. Okay, it's 1 plus 1 minus 2 plus 1 plus 1 minus 2, etc., etc. Okay, you can see this pattern goes forever. So first find the k's partial sum. K's partial sum is just, right, for example, s1 is just 1, right? It's just the first term. That's s1. S2 is the sum of the first two terms. Okay, it's 2. S3, it's the sum of the first three terms. It's 0. Okay, etc., etc. So as you can see, this sum is going to be 1, 2, 0. Okay, then what's the sum of the first four terms? It's 1. What's the sum of the first 5 terms? It's 2. Right? What's the sum of the first 6 terms? It's 0. So you can see this sum, it's 1, 2, 0, 1, 2, 0, etc., etc., right? So this infinite sum, it's never gonna be closer and closer to a specific value, okay? Because a partial sum, it's alternating between 1, 2, and 0. Okay, so this series is divergent. Okay, so this series is divergent. Part 2, we have sum, right, n from 1 to infinity a. Okay, so what is this? It's just a plus a plus a forever. Right? And you already know a is not 0. Okay, so again, what's the k's partial sum? What's S1? S1 is just the first term, it's a, right? What is S2? S2 is the sum of the first two terms, it's 2a. What is S3? S3 is the sum of the first three terms, it's 3a, right? So as you can see, a is not 0, so let's write it down, right? So Sk is just ka. Okay, Sk is ka. And then this series is exactly the limit of the k's partial sum when k is approaching infinity. Okay, they are exactly the same. So it is the limit of ka as k is approaching infinity. Right, so you can see a is non-zero, right? So this limit, it's going to be positive infinity if a is positive, and it's negative infinity if a is negative. Right? That's it's going to be the series. So either way, this series is going to be divergent, right? Because it's either positive or negative infinity, so it is a divergent series. The infinite sum is not a real number, okay? Or it's not closer and closer to a real number, okay? So let's do part 3. Part 3, it's an infinite sum, right? N from 1 to infinity, a times -1 to the power of n minus 1. All right, you want to get sk. Okay, so again, let's write it down. So so when n is 1, right? When n is 1, here it's -1 to the power of 0, which is 1. So it's a, right? When n is 2, here 2 minus 1 is 1. So it's -1 to the power of 1. It's just -1. So it's minus a. Okay, plus a, minus a, plus a, minus a, etc., etc. Right now, so what's the first? What is S1? S1 is just the first term. What is S2? S2 is the sum of the first two terms. It's 0. Right. What about S3? S3 is going to be a again. S4 is going to be 0 again. So you can see the partial sum is alternating between between a and 0. Right? It's alternating between a and 0, so it is divergent. Right? It's never closer and closer to a specific value. It's forever alternating between a and 0. Okay, so it's divergent. Right? And also very important, we know a is not 0. Okay, so if a is 0, it's another story, but we know a is not 0. Okay, from the question we know a is not 0, so it is divergent. Right. So problem 4. Problem 4. It is so before problem 4, let's talk about geometric series. Right? Geometric series, very, very important. Geometric series. It is, okay, it looks like n from 0 to infinity, a times r to the power of n. Okay, this is our geometric series. So let's expand it. It is like when r is, right, when n is 0, it is 1, so it's just a plus ar plus ar squared, right, plus ar cubed, etc., etc. Okay, so you can see each term is a previous term times r. R is ratio, right? That's why it's r. Okay, so this infinite sum, this series, it's divergent, right? It could be convergent. It could be divergent. Okay, it is convergent if the absolute value of r is smaller than 1. Okay, it is divergent if the absolute value of r is greater or equal to 1. Okay, so that's why it's important, because suppose we know a series is geometric series, we just need to look at the ratio. Right? If the absolute value of the ratio is smaller than 1, we know it's convergent. Otherwise, we know it's divergent. Okay, so if it's convergent, that means, right, we are able to get the sum. Right? So what is that sum? The sum is also very easy. It's a over 1 minus r. Okay, it's a over 1 minus r. If it's convergent, that sum is this. Okay, if it's divergent, it doesn't have a sum. Okay, it doesn't have. You can't write it down. You can't write down the sum. Okay. So another special case, right? Another special case. This is a sum from 0 to infinity. What if you write this geometric series, okay, from 1 to infinity? So if you write it, the geometric series is from 1 to infinity. Essentially, it's just ar plus ar squared plus ar cubed, etc., etc., right? Etc., etc. So you can see, you compare this with this, it misses an a here, right? It doesn't have an a here. Okay, so you can see this sum is just this sum minus a. Okay, so if it's from 1 to infinity, is just this sum minus a, because a is a zeroth term. So if this sum minus a, it's going to be AR over 1 minus r. You can do the calculation by yourself. Okay. So let's take a look at problem 4. It is summation n from 1 to infinity negative 3 to the power of n minus 1 over 4 to the power of n. So first we want to reorganize it to make it look like this. Then this is a summation n from 1 to infinity. Okay, so I want my top to be also something to the power of n. So I have an extra negative 1 here. Right, so it's negative 3 to the power of negative 1 times negative 3 to the power of n over 4 to the power of n. Okay, which is here, negative 3 to the power of negative 1 is just negative 1 over 3, okay, times negative 3 over 4 to the power of n. Okay, now if I write it in this way, it's quite clear. This is my a, this is my r, right, to the power of n. So all I need to do is write whether this r is, the absolute value is smaller than 1 or not. Okay, and we can say that it is convergent since, right, the absolute value of 3 over 4, the absolute value of r is smaller than 1. Okay, so this series is convergent. Okay, this series is convergent. Then, what is that? What is the infinite sum? You can just apply this formula. It's a, which is negative 1 over 3, times r, right, over 1 minus r. Okay, over 1 minus r. So you can do that. It's just 1 over 7. Okay, it's just 1 over 7. All right, problem 5. Summation n from 1 to infinity 12 times 2 to the power of 2n minus 1 over 3 to the power of n. Okay, so again, you want to change it to a times r to the power of n first. So, right, so it's 12 times 2 to the power of negative 1 times, right, 2 to the power of 2n is just 2 to the power of 2 to the power of n, right? It's just 4 to the power of n. So times 4 to the power of n over 3 to the power of n. Okay, which is n from 1 to infinity. Okay, this part is 6 times 4 over 3 to the power of n. Okay, again, this is a geometric series. Right? Again, it's a geometric series, and you can quickly conclude that it is divergent since, right, the geometric series ratio r, which is 4 over 3, is greater or equal to 1. Okay, it's greater or equal to 1. So, yeah, so it is divergent.